Hello. We're looking at derivatives of logs. I'm doing question 2G, exercise 2G, question 2. I thought G, H, and I looked interesting. Looking at some of the other ones, maybe 2E, I can see a chain rule. Here, I can see what you could do with a product or a quotient rule. But G and I look sort of similar, might be interesting. And then this H kind of looks a bit odd, the log of log X. So let's take a look at those. If we're trying to find the derivative of log 1 on X, right, we take what's in the log and we do the reciprocal of that. So we'd have 1 on X, which is just the same as X. And then we need the derivative of what's inside that log. Now what's inside that log might be easier to see if I write it like this, right? Will be the derivative of x to the power of minus 1, which will be minus x to the power of minus 2. 1 divide 1 on x. All divide 1 on x. We could times by x. Times by x. These x's cancel. You're just left with x. So we get x times minus x squared. That's the same as, so we'll put the minus up here, I think. The x's cancel here, so you're left with minus 1 on x. Now, it might have been easier to rewrite this log like so. If I've got y equals log x to the minus 1, in fact, I'm pretty sure it's much easier. I could have used a log law and said I've got minus log of x there, and found the derivative, right? So I keep the minus. Derivative of log x is 1 on x, and we get to the answer quite a bit quicker. If we look at this function here, what would it look like as a graph? Given that here's my normal graph for y equals log x. In this function, we have to the power of minus 1, or we bring the minus out. So all of the y's are going to be negatives of what they were. So the graph ends up being over here instead, like this. Excuse me, having a brain moment and a big lunch. What I said was right, what I drew wasn't. All of our outputs that we would normally get for log x, all of the positive ones will now become negative, and all of the negative log x's will now become positive, because it'll be negative times negative. So we end up with a reflection about the x-axis. So we actually end up with this shape, don't we? Like that. That's better. So there's y equals minus log x. Now, they're saying the derivative is negative 1 on x, and you can see that the slope for this curve, should have put an arrow there, the slope is negative the whole way down, right? So there's a bit of intuition to that answer. Maybe we jump to this question here, I wonder how well I can draw a straight line. Break these into 3 columns. There we go, beautiful. If we go y equals 1 on log x, I think I'd like to write it like this. so that I can apply a chain rule to it more easily. I'm going to say the derivative will be minus log x to the minus 2. So I'm looking at the outside. Then I look in the inside and I've got log x, and the derivative of that is 1 on x. So we end up with minus 1 on x, and then I've got my log x squared here. And just make sure that you're showing that it's all squared. Right? So that one's quite different to this log of 1 of x. 1 on log x, the derivative came out quite differently. What about h? Seems a bit odd, a log of a log. But the same rule applies. If we had y is log x, we know the derivative is 1 on x. So we're doing the same thing. We're saying the same procedure. We've got log of something, right? The derivative of that will be the reciprocal of 1 on that something, which will be this. And then I need to go to the inside of that function and say, what's the derivative of log x? It's 1 on x. And then to tidy it up, I get 1 on x log x. Okay. Now, I wanted to add a couple more questions to this video. Actually, I'll just do one more. I wanted to do one where you have to split up the log. So we go back to the textbook. Maybe in question 4 there's some. Question 3 has these as well. So it's saying use the laws of logarithms to help differentiate. Now, in a test or exam, they're not going to give you that hint. They're not going to say simplify this first, all right? So just be aware of that. You'll have to be able to pick when can I apply a log rule. You need to be on the lookout for that. Okay, like maybe the first one, it's not that obvious, but I've got a log of 1 minus 2x all to the power of a half. Right, we're logging all of that. We can pull the half out of the log. Okay, you've got to be on the lookout for when you can apply a log rule so that you can differentiate. Or here, this is saying if I've got log of a divide b, the book was using a's and b's before, we could rewrite that as log a minus log b because we're dealing with powers here. So maybe you just have to get used to or tell yourself before a test or before the exam, where if I see a log and I'm doing calculus, think, can I simplify the log? Maybe we did the last one here, d. So we've got log of x cubed, x plus 4x minus 1, using function notation. On. It was a 4 and a 1. I'm just trying to write this down before I forget the numbers. I'll still have to check. And obviously we're logging all of that. Plus 4 and a minus 1. Yep, okay. So first thing we can do is rewrite the function as log of x cubed minus log of all of this, x plus 4 times x minus 1. Right, so that's using the rule that I just wrote out. Here we've got a situation, so just in this second log here, here's the log law that applies for this. Right, we can split this log up as well, so no need to expand this or anything like that. Just be careful. I would be using brackets here, because you need to subtract everything here. So let's use these large square brackets and then split the log up. Because what I've really got is minus this log and minus this other log as well. And that should be obvious if I use brackets. Okay, so I've got minus log x plus 4. And then I've got minus log x plus 1. Sorry, minus 1. So nothing unusual there. You're used to dealing with brackets in that way. Now I can come along and finally find the derivative. I think, well, all right, what's the derivative of x log x cubed? So we do 1 on the x cubed. Then we look on the inside of this function and find the derivative of x cubed, and that's 3x squared. Here, I think things will be a bit easier. We've got 1 on x plus 4. What's the derivative of just the x plus 4? Well, it's just 1, so that stays as is. And here I've got 1 on x minus 1. That's dealing with the log. Then I look inside. I think, what's the derivative of x minus 1? It's just 1. So nothing needs to be done there. The only tidying up we're going to have is here with an x squared divided by an x cubed. So we end up with 3 on x there, minus 1 on x plus 4. And you can see that as long as we get to this point, we get to here, our life becomes pretty easy from then onwards. So be on the lookout for, can you simplify logs? Or can you apply log laws to the logs to make them easier to differentiate?